Okay, these two smooth spheres are coming together. We've got the masses given, and A is moving at 5 meters per second in direction, where cos alpha is 4/5. So cos alpha equals 4/5, our 3, 4, 5 triangle. So that means that sine alpha equals 3/5. And so that means sine will be the one opposite the angle. So that bit there is going to be 3/5 of that. So that'll be 3 meters per second. That bit there will be 4/5. So that's 4 meters per second. So that's quite nice, them giving it like that. And the other bit, cos beta, so cos beta equals 5/13. So that's nice as well. That means that sine beta equals 12/13. And again, here we've got that's 13/4. So that's our 13/4. So that bit there, sine is opposites, so it'll be 12/13 of 13/4. So that will be 12/4, which equals 3 meters per second. And the bit going this way is going to be 5/13 of 13/4. So that'll be 5/4, or 5/4 meters per second, like that. Interesting that's going at 3 that direction, that's going at 3, so they will remain in the same line. The lines will still be perpendicular to here. So what have we got to do? Oh, E, coefficient of restitution, is 2/3. Okay, I've got to find the speed of A after collision. Well, it's still, that's part 1, parallel to wall. So parallel to wall is still 3 meters per second, because there's no change in momentum, because the impulse is this way. There's no impulse going parallel to the wall. So I now got to work out the other bit. So it's now got things I need to work out which are going to go. I'm going to say that B goes that way at B, and I'm going to say that A goes that way. Otherwise my arrow is going to get a bit confused. So that's how I'm going to have it. And I'm going to have to look at conservation of momentum. So cons of momentum and I preferred words. So total init momentum equals total final momentum, and I'm going to take that way as positive, and I know that direction matters. So what have I got to start off with? I've got the mass 2m times by 4, and then I've got, obviously going to have to take away 3m times by, that's 5/4. And that does the first bit, and that equals the final momentum. Well, I've put A to the left, so that'll be minus 2ma, and then I'm going to have plus 3mb. Simplify that, all the m's cancel out, so m's disappear, and that will give me that 4.25 equals minus 2a plus 3b. So I've got A and B, one equation. I need to get another equation. Pretty obviously I'm going to have to use E equals separation speed over approach speed. And so E, that's 2/3, equals separation speed. Well, they're going apart from each other here, so that'll be A plus B. And it'll be over my approach speed. Well, this comes in at 4, and this one comes in at 5/4. So that'll be 4 plus 1.25, or 5/4. And if I take that through, that's going to give me, that's A plus B equals 2/3 times by 5.25. And I'll say that's A plus B equals 3.5. Now that's much better, so I've got two equations, two unknowns, So if I double this one, I get 2a plus 2b equals 7. And this one can come up here and give minus 2a plus 3b equals 4.25. And that will work out, add those together, 5b equals 11.25. So b will equal 2.25 meters per second. And put that into there. And that will say that a equals 1.25 meters per second, but that's not the answer. So I've got to find the speed of A after the collision. So therefore it goes 1.25 that way, and it goes up there at 2.25. No, it goes up there at 3, the original velocity. It goes up there at 3. And so the speed of A equals the square root of 3 squared plus 1.25 squared, which equals 3.25 meters per second. And that does that bit. Find also the component of the velocity of B along the line of centres. Well, I've done that. Component of B is 2.25 meters per second. So I've already done that bit. That's 7 marks. That's okay. Explain why A and B will have a second collision if the coefficient of restitution between B and the wall is sufficiently large. Well, that is because I don't want to write it all down because I'm going to be saying it anyhow. I've already said the velocities are vertical 3, so both verts velocities are 3 meters per second parallel to wall, and A is going away at A is moving at 1.25 to the left, and B is coming in at 2.25. So it is going to have enough to get to bounce back. If it were to be perfectly elastic, it would bounce back at 2.25, which would catch up the 1.25. So what we're going to do, we're going to find E when B bounces at 1.25, and E must be greater than that. So now E equals sep over approach, and separation speed must be 1.25, and the approach speed is 2.25, and that will equal 5/9, and E must be greater than that. Therefore, E is greater than 5/9. Because if it were to equal 5/9, they would bounce back at exactly 1.25, and therefore it would keep exactly the same gap between them the whole time. And that's question 3 done.